In this video, we're going to be looking at the derivatives involving inverses worksheet, and it's 13 questions. Okay, number one. Let f and g be inverses. Before we even do that, let's remember that if f and g are inverses, and we say, hey, there's this point, f of a equals b, we know that there must exist on the inverse function an inverse point, g of b equals a. So we switch those x's and y's. Remember also there's a relationship with the slope, right? So if f prime of a equals m, then the slope, not at a, but at the inverse point, g prime of b, is the reciprocal of this slope, 1 over m. Okay, remember, because we're switching x's and y's, and slope is y over x, so we switch that x and y, and so suddenly we've got our old x up here and our old y down here. Okay, so let's look at these problems with that in mind. Differentiable inverse. Differentiable inverse. Our function can have a I'm going to have to think about that one. Okay, 1. Let f and g be inverse functions so that they're differentiable for all x. F of 3 equals -2. So we know then that g of -2 equals 3. And then they tell me that g prime of -2 equals -4. And so going this way, I know that f prime of 3 would equal the reciprocal of this, -1/4. So which of the following statements must be false? Oh my goodness. All right, f prime of 0 is 1/4. F prime of 0 is 1/4. Well, that can't be true because they can't have opposite signs. And here's why. Okay, so I have a function. It has a positive slope, a 0 slope, and a negative slope. And our function has a negative slope. But this function doesn't pass the horizontal line test. And so what we find is we can't have if this slope is negative, then all the slopes on f have to be negative, because once I get to that 0 slope and back to a positive slope, I'm going to fail that horizontal line test. So I can't have any other negative slopes. Okay, which rules out 3. F prime of 5 equals -1/4. Can't have the same, can't have the opposite slope is what I was saying with 1. So f prime of 0 equals 1/4. See, these are opposites. I can't have those. Okay. 2 is f prime of 3 equals -1/4. That's our answer. So that can't be false. So what can be false? Well, so far we figured out that can't be false. Oh, well, that one can't be. Maybe there's more than one. So let's keep looking. 3. We know this is true for sure. And f prime of 5 can equal -1/4. Well, it's true that f prime of 5 can equal negative 1/4. We could have a negative slope, a negative slope, a negative slope on our f function, and the slope here and the slope over here can both be negative without me going positive in between. So that can be true, that is true, and that can't be true because inverses are monotonic. They're either always increasing or always decreasing, and so they can't have opposite signs, or else we won't be able to pass the horizontal line test to make the inverse in the first place. So my answer here is A, 1 only must be false. See, that's why we're doing this packet. 2. Okay. 2 says a decreasing function, g, satisfies, and they tell us decreasing so that we know that g is monotonic, it's always decreasing, and therefore g can have this inverse. Satisfies the condition that g of 4 equals 6 and g prime of 4 equals negative 2. Which of the following statements must be true? All right, well, let's think about the inverse. G inverse of 6 must be 4, and G inverse prime of of 6 must be negative 1/2. So at the inverse point, the slope is the reciprocal of the slope at the original point on the original function. Okay, so what are my choices here? Which of the following must be true? So we've got G inverse prime of 6 is 4. No, that's not true. G inverse prime of negative 2. No, that's not true. G inverse prime of 6 equals negative 2. No. Oh, there's our answer. G inverse prime of 6 equals negative 1/2, and so the choice is D for number 2. For number 3, let f and g be inverses so that they're differentiable. Okay. And remember that also implies continuity. F of negative 5 equals 7. So g of 7 equals negative 5. We know that g prime of 7 equals 3, and therefore f prime of negative 5 must be 1/3. So at not this point, but at the inverse point on the original function, we've got a reciprocal slope. So which of the following must be false? This is like problem number 1. Okay, so we know that it must be positive 1/3. So 1, where it says f prime of 3 equals negative 1/3, nope, we can't have that opposite slope from our positive slope. We know that f and g are differentiable, but they also must be monotonic for them to be inverses of each other. And so if f is got a positive slope, then f always has a positive slope and can never have a negative slope. Okay, what about 2? 2 says f prime of negative 5 equals 1/3. Well, that's our answer. Yes, that's good. And 3 says f prime of 7 equals positive 1/3. Again, with the positive slope, I can't have that positive slope. Hold on a second. It's good when you open your eyes. This says negative 1/3. I can't have this. This is our slope, yes. And this one is the same as this one, and these can be the same. And so for number 3, I'm looking at A, Only this one must be false because I can't have that opposite sign slope. Okay, there's 3. 4. 4 says, which of the following increasing functions does f inverse prime of 20 equal 1/5? Okay, so that's the inverse function slope at 20 is 1/5. And we're told only that. And then we look at these functions. Okay, so A says x plus 5. Well, we know this, all right, maybe we don't know. We can find the inverse here by switching the x's and y's and solving for y. So x minus 5 equals f inverse. And if I plug in a 20, oh, and I want to take the derivative, f inverse prime, and I get 1. Well, 1 is not 1/5, so that one doesn't work. What about B? B says x to the third plus 5x plus 20. So this I can't make the inverse of. And I also suspect that it does something like that. And as a result is not going to have my proper inverse. But let's just see. Let's just see if the facts exist. So f of 20, oh, that's f inverse prime of 20. Is there a point on f where the y value is 20? Well, sure, there's a point at 0 when the y value is 20. So what's the slope at 0 on the original function? Well, that would be 3 times 0 squared plus 5 times 0 plus 0, which looks a lot like a 0 slope there. And lo and behold, I need a slope of 1/5. So that one doesn't work out. Oh, sorry, the derivative of 5x is 5. Oh, 5. Look at that. So on the original function at the original point, we have a slope of 5, which would mean on the inverse function at the inverse point, I would have my 1/5. Oh, so B could be good. Let's take a look at C and D. C says x to the 5th plus 5x plus 14. So I'm looking and saying, is there a place when the output from this function is 20? And I've already got 14 here, so I would need 6 more. Oh, look, f of 1 is going to equal 20. Okay, so let's take the derivative of this. F prime would be 5x to the 4th plus 5. And what can we say about f prime of 1? Well, that would be 5 plus 5, or 10. And therefore, f inverse prime at 20, if this is 10, would be 1 over 10. So that one doesn't work. That one doesn't work. And finally, we have D. D says e to the x plus 5, x plus 19. Okay, so if this is f, and we go back to f of 0, we can get a 20. But f prime is going to be e to the x plus 5. And if I plug a 0, I'm sorry, if I plug a 20 in here, I get e to the 20th plus 5. So that's not going to be our slope of 1/5 at the inverse point. So D doesn't work as well. B is our answer. And my initial trepidation about this is overcome, well, by brute force, showing all the others don't work. And so really I didn't need to worry about this happening. Okay, 5. 5 says, on an increasing function f satisfies f of 10 equals 5 and f prime of 10 equals 8. And so what do we know? We know that there's an inverse function with this inverse point on it, and we know that this inverse function's derivative at that inverse point must be the reciprocal of the original function at the inverse point. Reciprocal of the slope, slope of the original function at the original point. So we want 1/8. Okay, so let's look at our choices for number 5. F inverse prime of 5 equals 10, no. Equals F inverse prime of 8, oh god, no. F inverse prime of 5, yes. Equals -2, no. And finally, F inverse prime of 5 equals 1/8. So D. D is our answer for number 5. 6. 6 says, the table to the right shows selected values for a differentiable increasing function and its derivative. This function is always increasing. That means that the derivative must always be positive. Might be useful to keep that in mind. If g is the inverse of this function, what is the value of g prime of 3? Well, I need to know f prime of something to figure this out, but I need to know this inverse point. When is the output of f equal to 3? In order to say what point must exist on the original function, right, there's g of 3 equals something, which means that f of something equals 3. So when does f have an output of 3? F has an output of 3 at 1. So we know this is true about f. And so what's the slope at 1 on f? The slope at 1 on f is 4. And therefore, the slope at the inverse point is the reciprocal of the slope at the original point. And so we can say g prime of 3 equals 1/4, which corresponds to choice B. B for number 6. Okay, 7. 7 says let f equal sine x plus 2x plus 1 and g is the inverse of f, and what is the value of g prime of 1? So when is the output of f equal to 1? Again, if I know that g of 1 exists, then f of something must be equal to 1. Well, how can I coax a 1 out of this? Ooh, I have a 1 here. If only these were equal to 0, well, they would be equal to 0 if I plugged a 0 in here. And so therefore my inverse point must be 1, 0. Okay, but what am I looking for? I'm looking for g prime of 1. So I need to know f prime of 0. F prime cosine x plus 2, f prime of 0 is cosine of 0 is 1 plus 2 is 3. So f prime of 0 is 3, which means that g prime of 1 will be 1/3. 1/3 is what I get for number 7, and that corresponds to choice A. A for number 7. Let's take a look at 8. It says f and g are differentiable everywhere if g is the inverse of f and g of -2 equals 5. And we know that f of 5 equals -2 because these are inverse functions. We want to know what g prime of -2 is. So we're going to say, hey, what's f prime of 5? So f prime of 5, they tell me, is -1/2. Therefore, g prime at -2 will be the reciprocal of this, -2. And I see -2 is E. E for number 8. Number 9. Number 9 on the back says, let f be defined in this interesting way. F equals 2x plus e to the x. Let g be f inverse. Okay. We know what else here. All x on 0 to 1. Okay. Is the graph which is the value of g prime of 1. Okay, so when is the output? That means g of 1 must exist. And that means that f must have an output of 1. When can I get an output of 1 here? Well, if this is raised to the 0 power, that becomes a 1, and that becomes a 0, and I get 0 plus 1. So I say f of 0. Okay, so that means this, and that means I want to find f prime. That's 2 plus e to the x, and I want f prime of 0, which is 2 plus 1 or 3. So if f prime of 0 is 3, g prime of 1 must be 1/3. G prime of 1 must be 1/3, and that's choice B. B for number 9. Okay, let's look at 10. The function h is given by x to the 5th plus 3x minus 2. We know that h of 1 equals 2. Then they start talking about an inverse function. What is the value of h inverse prime of 2? Well, we know there exists h inverse of 2 equals 1. Well, what about h prime? H prime is 5x to the 4th plus 3. And I want to know h prime at 1, which is 5 plus 3 or 8. Therefore, h inverse prime at the inverse point must be the reciprocal of this, 1/8. And so I get 1/8, and that's also choice B for number 10. Okay, let's take a look at 11. 11 and 13 definitely look like free response questions, so maybe there'll be more than this stuff. Let's see, 11, no calculator. F prime of x equals sine pi x plus x squared plus 3. and f of 0 equals 2. Write the equation of the tangent line to the graph y equals 1 over f. That's the same as, I hate these people. Look, that's not inverse. That's reciprocal. Because I didn't want to use the quotient rule. Because if I want to talk about f prime, if I want to talk about y prime, I need to say negative 1 times f to the minus 2 times f prime. So that's the derivative of this y function. And why do I need that? Because I'm writing the equation of the tangent line at x equals 0. And remember, in order to write the equation of the tangent line, we need two things. We need a point and a slope. So luckily, I know f of 0 is 2. So I have, well, I don't quite have a point. That's f. I'm asked to write the tangent line to y, which is 1 over f. So y of 0 is 1 over f of 0, which is 1 over 2, or 1/2. So my ordered pair is 0, 1/2. Now, I also need y prime at 0. Well, here's y prime. It's negative 1 times f prime over f squared. And I want the derivative at 0, and f of 0 squared. Well, I know f of 0 is 2, so f of 0 squared is going to be 4, and f prime is this function up here, and if I plug a 0 in here, I get 3, so I get negative 3/4. So I'm looking at y minus 1/2 equals negative 3/4 x minus 0, and if I wanted to take this further, I guess it could be y equals negative 3/4 x plus 1/2. Okay, there was part A. That took the whole board. Let's see about doing B. Oh, there's B. B says G is defined as f of the square root of 3x squared plus 4, and we'd like to know G prime of 2. So G prime is f prime, leave that stuff alone, times the derivative of the square root times the derivative of that innermost function, which will be 6x. And we want G prime of 2. Okay, that's going to be f prime of 2 squared is 4, 4 times 3 is 12, 12 plus 4 is 16, square root of 16 is 4, times 1/2. 2 squared is 4 times 3 is 12, plus 4 is 16. That's negative 1/2, so I get 1/4, times 6 times 2, or 12. Well, what about f prime of 4? What do we know about f prime of 4? Oh, well, remember they gave me that f prime function that they said was sine pi x plus 3x, plus x squared plus 3. And so if I want f prime of 4, then that's the sine of 4 pi plus 4 squared plus 3. 4 pi looks just like 2 pi, looks just like 0. Sine of 0 is 0, so I get 19. So this is going to be 19 times 12 over 2 times 4. I can do some canceling, and that's 57 over 2, I believe, is what I get for that one. 57 over 2. Yes. Good. Doink. But we still haven't gotten to an inverse question yet, so I'm expecting that to show up here in C. Let H be the inverse of F. Oh, thank God it's not the inverse of Y. And what else do we know? Find H prime of 2. Well, if F is the inverse of H, then there must be a place on F when the output is 2. And conveniently, they gave us that point. They said that F of 0 equals 2. So we know that H of 2 equals 0. Okay. Now, in order to find H prime of 2, I need to know F prime of 0, because I need to know the derivative at this inverse point. Well, we can plug in a 0 into our sine pi times 0 plus 0 squared plus 3 and get a 3. So at the inverse point, the slope must be the reciprocal of this slope, and I get 1/3. 1/3 is the slope on H at 2. The slope on the original function at the original point is 3. The slope on the inverse function at the inverse point is the reciprocal of that original slope at the original point, therefore 1/3. Okay, there's 11. Let's take a look at 12. 12 says functions f and g are differentiable. G is strictly increasing. That means it passes the horizontal line test, and we know therefore that g can have an inverse. The table at the right gives values for the functions and their first derivatives for selected values of x. If g inverse is the inverse of g, write the tangent line to the graph y equals g inverse of x at x equals 2. Okay, tangent line to g inverse at this point. Well, so I don't have g inverse information on the chart, but I do have g information. And so when does g have an output of 2? According to the table, g has an output of 2 when x is 1. So we know that g inverse of 2 would equal 1. That means we have our ordered pair, our point. Our point for writing this tangent line happens at 2, 1. Now what we need is g inverse prime at 2. Well, in order to figure out the slope on the inverse function at the inverse point, we need to first think about the slope on the original function at the original point. G prime of 1 is 5. Therefore, g inverse prime of 2, that's the inverse point, would be 1/5. So now I have a slope and a point, and I can write the equation of the line y minus 1 equals 1/5 x minus 2. And I believe that's good to go here. If you want, you can always, tidy this up and make it 1/5 x minus 2/5 plus 5/5 would be plus 3/5. But I say just stop there if this is free response, which this looks like. Okay, and then our last question, 13. 13 says, a graphing calculator is required. Well, that's good to know. Table shows selected values. F of 3 equals 2. And derivative f prime equals x cosine e to the x. Well, I suspect that's why I need a calculator, but let's see. Oh, and we were given a table with g values in it. I see. So this is like that multiple representations worksheet we had, where we had to be able to understand things both algebraically and from a table. Okay, so part A says f double prime of sine of 2. Express your answer as a decimal approximation. Well, so I've got f prime of x, and they want f double prime of sine of 2. And that just means I need to take the derivative of this, and please, Delaney, don't do it by hand, right? They said with a calculator. So go to your calculator and type in that function into y1, x cosine e to the x close 2 parentheses. Make sure you're in radians. Good. And now we want the derivative of that. So we go to math and deriv y1 comma x comma x. Okay. So in fact, I'm going to turn off this first function. And I don't even need to look at the graph. I just need to go over to my table and plug in sine of 2. So I go over to my table and I type in sine of 2, and I end up with negative 2.173, and I'm all done. See, that wasn't so hard. It's, whoa. But that's not what I got when I did it before. So what happened? What did I just do wrong? I better go check that one. Sine of 2, f double prime. They've given me f prime. So to find f double prime, I take the derivative of the sine of 2. Well, that makes complete sense to me, but why do I get a different answer here? All right, I'm going to go back and check my typing x cosine e to the x. I want the derivative of that function for all x's. Yes, I think that's the case. They asked about f, and this is f prime, f double prime of sine of 2. So I'm going back to the table and I'm typing in sine of 2 again. And I get the same answer. Oh, I better go check that one. Huh. All right, I'll go check that one. That's, I'm only concerned because it's not the answer I have written down on my work, which was negative 12.761 with a calculator. And I'm not sure how that happened, so I'll let you know in class. B. 13b says h is defined as g of f of 2x. So this is a chain rule question. They want h prime of x first, which would be g prime of f of 2x times f prime of 2x times 2. And they want h prime of 3 halves, or 1.5. In fact, since I'm probably going to do it on the calculator, I'm going to do 1.5. Okay, so g prime of f of 2 times 1.5 is 3, times f prime of 3 times 2. Okay, so f of 3, they gave me as 2, so this is g prime of 2 times f prime of 3 times 2. Well, f prime is this function. G prime of 2 I get from the table, that's negative 3, times f prime of 3 times 2. So I've got negative 6 times f prime of 3. And I'm going to do f prime of 3 on my calculator. At least I hope I am. This is f prime. So I'm going to turn that one back on. And I want f prime of 3. And I get negative 0.05. I'm sorry, positive 0.98578 times 6. So 0.98578 times negative 6. And I get negative 5.9146. Yes, so negative 5.1915, rounded to 3 places. And that's good. There's my h prime of 3/2 equals that. Great. C, write the equation of the tangent to G inverse at negative 2. Okay, so G inverse of negative 2. Well, that means on G there must be an output of negative 2. When does that happen? G has an output of negative 2 at 3. So we know that G inverse has a point negative 2, 3. And we want to know G inverse prime at negative 2, which means we need to find G prime of 3. G prime of 3 we get from the table. G prime of 3 is negative 4. So therefore, the slope on the inverse function at the inverse point is negative 1/4. And we can then say our tangent line, y minus negative 4 equals negative 1/4 x minus 3. And since this is free response, I'd probably stop there. But I guess you could take this further. Why is my answer different? I've got the negative 1/4. This is the point, negative 2. Sorry, I used the derivative information, not the point on the inverse function. So this is a minus 2, and this is a 3. Okay, so we get y minus 3 is negative 1/4 x plus 2. Again, I'd probably stop here, though you can certainly tidy this up if you like, and you should end up with negative 1/4 x minus 2/4 plus 12/4 is 10/4 or 5/2. There's our tangent line for part C. Okay, finally we have D, and D says the point 3, 1 lies on the curve in the xy plane given the equation f squared x plus g of x plus equals xy minus 1. What's the value of the derivative at that point? Okay, so the derivative would be 2 times f times the derivative of the inside function f prime plus g prime equals, the derivative over here is going to be 1 times y, product rule, plus x times dy dx, and the derivative of that is 0. Okay, so I'm looking for dy dx. I need to plug in 3 for all the x's and 1 for all the y's. So I've got 2 times f of 3 times f prime of 3 plus g prime of 3 equals 1 times 1 plus 3 times dy dx. Okay, so I can get g prime of 3 off the table. That's negative 4. They gave me f of 3 was equal to 2. So this is 2 times f prime of 3 plus that equals 1 plus 3 dy dx. F prime of 3, I think f prime of 3 was this thing we found before. Here's 3. Here's f prime. Here's f double prime. So f prime of 3 is 4 times 0.9857884 minus 4 equals 1 plus 3 dy dx. So I'm going to take that number and multiply it by 4. I'm going to subtract 4 from that number. I'm going to subtract 1 from that number. I'm going to divide that number by 3, and I get negative 0.352 as the derivative as dy dx at 3, 1. Let me just check my answer. Yes, that gets smiley face, and we're all done. All right, I hope this helps, and I hope you feel more confident with doing the derivatives of inverses. Have a great day.